So previously we covered looking at collinearity with points in three-dimensional space. So that was imagining being able to draw a vector between 3 points and all 3 of them lying on that same vector. Now to do this, what we had to do was look at 2 vectors within the 3. So if we had 3 points A, B and C, we'd maybe look at the vector A to B, B to C, or A to C, B to C, any combination like that. And what they had to be was scalar multiples of the same base vector. If that was the case, then all 3 points were collinear in that 3-dimensional space and scenario. What we're going to do is take this and extrapolate it and apply it a little bit further. We're going to look at something called the section formula today. Now, the easy way to think about that is with this 3D demonstration. Imagine we've got 3 collinear points. Now, the section formula is something we can use to find the coordinates of the in-between point if we know the endpoints of the line and the ratio the line is divided up into. So imagine we've got a 3-dimensional scenario like this with an X, Y and Z axis, and I've got 3 points in 3D space. So a point A and B at the end of the line, and the point P somewhere along the line. Now imagine I tell you that P divides the line A to B in the ratio of M to N. So in the ratio of M to N being the whole line. What I can do is use this information in order to be able to calculate the coordinate of the point P. Now, another couple of things we need to make sure we remember is the position vectors relating to each of these. So the position vector A from the origin to A, position vector P from the origin to P, and the position vector B from the origin to B. We have to make sure we remember all 3 of those because they're going to come in handy. Now, in order to find this, what we do is we imagine we look at A to P and P to B. If we look at those 2 across the entirety of that line, what we know is that the ratio of A to P to B is the equivalent of the ratio of the 2 parts of the line. So it's the equivalent of M over N. Using this information, we're actually able to figure out a formula to get P. What to do if you cross multiply to get rid of the bases of your fractions? You get N times AP equals M times P to B. Now A to P, remember, is P minus A, so your 2 vectors taking away each other, and P to B is the same sort of thing, the B minus P. Put that in, and you get N bracket P minus A equals M bracket B minus P. What we can then do is multiply out these 2 brackets, and we get NP take away NA equals MB minus MP. So we've kind of got various parts here of different bits of an equation, but think about it, we want to solve for P. If we were to solve for an equation in any other step of algebra we've done before, we'd get everything we wanted to solve for on the left side, everything else on the right, and take it from there. Well, same logic here. Get all the P's over here, everything else across here, and we'll be able to solve. So if I shift the MP across here, I get NP plus MP, which means I can take out a factor of P and get N plus M times the P. Shift the NA over here, and I get N times A plus M times B. What I want left is the P, so divide through by the N plus M, and I get that P equals NA plus MB over N plus M. Now remember, position vector P tells me the relationship between the origin and the point. So if I know the vector P, I can just read that off and turn it into a coordinate form to get the coordinate of P. This here is what's called the section formula. This allows me to find the point along any line if I know the 2 ends and the ratio it divides it up into. And it's got various applications and things we can do. I'm going to show you a couple of them now. Now imagine I give you 2 points, a point A here and a point B, and I'm telling you they're divided by this point P in a ratio of 2 to 1, and I want to find P. This is the kind of thing where we have to immediately remember our formula and what we need to be able to do. So a point P is NA plus MB over N plus M. Now a key thing you need to make sure you get right in this case is what the N and the M are, what parts of the ratio they relate to. Now, think about your line from A to B, and it's divided by the point P. It's in the ratio of 2 to 1, which means that's 2 and that's 1. If we want the N, which is with the A, it's over here. The M is there. So there's your M, there's your N. A good way to remember it if you draw arrows going across, that tells you the parts of the ratio that go with the A and go with the B, or the X and the Y, whatever coordinates it gives you there. So I know that the M is 2 and the N is 1. Substitute all of that into your formula, and you get 1 times the A, which is given by this, so -3, -1, 5, plus M, which is 2 times the B, given by this, 3, 2, and 8, and that's all divided by N plus M, which is 3. So that's going to be the equivalent of 1/3 times all of this put together. So 1 times that's just this vector, plus twice this, so -3 plus 2 times 3 gives me 3, -1 plus 2 times 2, -1 plus that gives me 3, and 5 plus 2 times 8, well, 2 8s are 16, 5 plus 16 is 21. So we've done this part, we've then got 1/3 of the 3, 3/21, so if we divide each of these by that, we then get 1, 1, and 7. So that's the vector we've got. I can then take it and say, right, P in the ratio 2 to 1, turn it into a coordinate, and it P being 1, 1, 7. So there you go. That's where the coordinate is, point P, if I look at it in this scenario here. Next kind of thing we can do is imagine I've got 3 points here, P, Q, and R, telling you that they're all collinear. I want to find the value of K and then the ratio which Q divides PR. So I'm going to look at this now. In order to get K, we have to think about how we did it before. Imagine we did P to Q and then P to R. Now remember, because they're collinear, they'll have the same sort of base as each other, they'll just be slightly different numbered. Once they're like that, we're able to figure out what the part is that we'll be missing, i.e. what the K will be there. So the PQ, what we have to do is figure out Q minus P to get that, and then we get an answer. Now the Q has the unknown part there, the K, so we're going to get some sort of an unknown equation part there. This will allow us to be able to then start to find what we're looking for. So Q minus P is 5 minus 6K, take away the P, which is -1, 3, -5. So we now go through each of the parts. 5 minus -1, 5 plus 1, that gives me 6. We then got -6 minus 3, gives me -9, and then K minus -5 is K plus 5. We then do the same of P to R, but in this case it's R minus P. So the R is given by the 9, -12, and 0, and that's then going to be take away the P, which is take away the -1, 3, -5. 9 minus -1 is 10, -12 minus 3 is -15, 0 minus -5 is 0 plus 5, which is 5. Now, with this one here, we have to start thinking about how they relate to each other and what the relationships to each other are. Well, if I take 5 out as a factor there, I've got 2, -3, and 1. Now this one here, if I take out 3 as a factor here, this becomes 2, which is there, and this becomes -3. So I've actually got the same two parts here. However, if I look here, this becomes 1/3 K plus 5 in my part there. So if I want those two to be the same, what I have to do is imagine this equals that when I take the 3 out as a factor, i.e. from that I can say 1/3 bracket K plus 5 equals 1. Shift the 1/3 over there, yeah, K plus 5 is 3, so K equals 3, take away 5, which is -2. So what I'm able to do is figure out the value of K from that, and I can use it to put in there. Imagine I put -2 there, like -2 plus 5 is 3, and if I take that out as a common factor, this bit here will be 1, so I get the same thing. So there you go, that's me got the value of K. What I now want to do is figure out the ratio which K divides P to R. Well, what to do is if you look at the various bits for the X, the Y and the Z and see how they go. So for the X, it goes from -1 to 9, that's 10. So 10 numbers all the way up. If you look at y, it goes from 3 to negative 12, which is in total 15. And then if you look at z, it's negative 5 to 0, and that's 5. So that's a jump of 5. Now, if you look at this part here, the q at 5, if we start at negative 1 and we get to 5, it goes 6. If we start at 3, and for q we end up at negative 6, it goes from 3 to negative 6, which in total is 9. And then this one here, negative 5 to k, well remember k is negative 2, negative 5 to negative 2 gives me 3. So we've got how far along we go to the q's. Well, if it's 10 to 6, that means I've done 6 to 10, which is 3/5. If I've got the 15 to 9, that gives me 9 over 15. Again, divide that through, which gives me 3/5. And this one here, the 5, and I've got the 3 part there, gives me 3/5. Now, what this tells me is that if I imagine going my whole line and I divide it into 5 sections, I've got 3 of those 5 sections between the P and the Q. i.e., an easy way to think about it, there's my line from P to R, and there's where the Q is. If I look at the line and I divide it into 5 sections, it's there to there. So my whole line divides into 5 sections, 3 of them between P and Q, 2 of them between Q and R. So what this means is the ratio Q divides P and R into is the ratio of 3 to 2, i.e. between P and Q is 3, Q and R is 2. So there you go, I'm able to figure out that. What we're able to do is use this as a key bit of information in order to be able to calculate missing points on the line, calculate the ratio lines get split up, and calculate how we can work these through and what we can do with them.